Welcome back to our lesson on percents. In this video, there's 4 practice problems that we'll try together. As always, I recommend that when a practice problem comes up, you pause the video and try it on your own first. All of these problems will be percent equations or use some kind of ratio. There might even be some dimensional analysis sprinkled in there too, because those are the 2 skills that you need for success on the RD exam when it comes to the math. The whole rest of Module 1 is just practice with this. So don't be discouraged if the next few problems feel challenging. And if they don't, excellent, because we will be applying these skills very soon. So let's get to it. This problem says raw chicken cooks down by 25%. If you have 1 pound of cooked chicken, how much raw chicken should you purchase? Well, we're given a percent here, so that's an indication that we need our percent equation. Percent is equal to our specific outcomes divided by our total outcomes times 100. So it tells us that we have 1 pound of cooked chicken. When we cooked it, it left us with 1 pound. Meaning this is our actual outcome. It's what we specifically have. But the percent here is not 25%. It says it cooks down by 25%. So what does that mean? Well, if you had chicken, if you had, say, 10 pounds of chicken and it cooked down by 25%, then that means what you're left with is 75%. So 75% is equal to our specific outcomes, 1 pound, divided by our total outcomes. Now, can you do this algebra? Well, let's walk through it. First, undo this multiplication. Divide both sides by 100. 75% literally means 75 over 100, 0.75. 0.75 is equal to 1 pound over our total outcomes. So we need to solve for total outcomes. But total outcomes is in the denominator. So we need to multiply both sides by total outcomes to get it out of the denominator. We could also cross multiply here. Total outcomes will cancel out on this side. And what we end up with is 0.75 times total equals 1 pound. But we want total outcomes. So to solve for our total outcomes, we again need to undo multiply. We have to divide both sides by 0.75. And what we end up with is 1.33 pounds. This should make sense. If raw chicken cooks down by 25% and you specifically and actually are left over 1 pound, you must have bought more than that. You must have bought 1.33 pounds. And you can always check this. Your 1 pound is your specific outcome divided by your total outcomes of 1.33 pounds. And if you plug this into your calculator, you'll be left with 75%. I have another one for you in the food service realm. When you wash and prep lettuce, 85% of the starting product can be eaten. That's our percent. It's not being reduced by 85%. You have 85% left over. How much lettuce will you need to buy if you need 20 servings and each serving has a half cup of lettuce? Since we're given a percent, it's a pretty good indication that we'll need to use this percent equation. However, this problem tells us that we need 20 servings and every serving has half a cup of lettuce. Each serving having half a cup of lettuce is an equivalent statement. Now, maybe you can do this in your head, but I would like to take a moment and show you how to use dimensional analysis on a problem like this. 1 serving equals half a cup of lettuce. That right there is our equivalent statement. And we need 20 servings. So since we need 20 servings automatically goes in the bottom to cancel out. Every 1 serving is half a cup of lettuce. So we need 10 cups of lettuce. There is no partial credit on the RD exam. So if you can do that in your head and you're confident on that, you don't need to show out the dimensional analysis. I just like to. It's really helpful for me. Now, this problem asks for how much lettuce we need to buy if we're only going to be left with 85%. So 85% is our percent. We need 10 cups specifically. That's what the recipe calls for. So how much total lettuce do we need to buy? First things first, get rid of that 100%, divide both sides by 100. 100 cancels out over here. 0.85 is equal to 10 cups over our total outcomes. Now, we have to do the same math that we just did on our last problem. To solve for total outcomes, we need to get it out of the denominator. So we have to undo division, multiply both sides by total outcomes. Total outcomes cancels out on this side. And we end up with 0.85 times total outcomes equals 10 cups. So to solve for total outcomes, we need to undo this multiplication. We have to divide both sides by 0.85. 0.85 cancels out over here. And that will tell us how much lettuce we need to buy. 10 divided by 0.85 is 11.76 cups of lettuce. Let's work on another one. This problem says that last week, a restaurant sold 6,000 sides, and 3,200 of the sides were steamed rice. This week is a holiday, and it is projected that 2,500 customers will purchase a side with their meal, so how many side orders of steamed rice should be prepared? Remember, pause this problem, try it, then come back and watch. Because this problem is a little bit trickier. It doesn't tell you this is a percent problem, but what it does tell you is that 6,000 side dishes were sold, and last week 3,200 of these side dishes were steamed rice. So we can find the percent of all sides sold that is steamed rice. And to do that, we'll use our percent equation. The specific outcome is 3,200 and the total outcome is 6,000. So in our calculator, 53.3% of all sides sold at this restaurant last week were of rice. But this week, we are only expected to get 2,500 customers, and we know that on average, only about 50% of the sides sold are rice. So how much rice do we need to order for this holiday week? This is another application of percent. 53.3% is the percent of sides sold that are rice. The total outcome this week is expected to be 2,500. So we're solving for our specific outcome. Can you do this algebra? This one is actually a little bit easier. We first need to get rid of this 100, divide both sides by 100 to cancel out our 100 on the right side, and we're left with 0.533 equals specific outcome over 2,500. So to get specific outcome, we have to undo division, multiply both sides by 2,500 on both sides. 2,500 cancels out, and we're left with the specific outcome, which for this case comes out to be 1,332.5 orders of steamed rice. Let's do one more, and I think we should get out of food science for this one. This problem says that we have a patient who's 5'9", admitted to the hospital, currently weighing 135 pounds. But records show that 4 months ago on admission, the patient weighed 152 pounds. So what is the BMI, and what is the weight change of this patient? Pause it. Try it. Both of these problems use the same foundational skills of percent. But BMI, you should know, is weight divided by height in inches squared times 703. That's not the only BMI equation. BMI is also equal to weight in kilograms divided by height in meters squared. This equation is going to make it so I have less math to do. You can use whatever equation you would like, but we have the height in inches and we have the weight in pounds, so I'll use the imperialist equation myself. And the equation for weight change is usual weight minus current weight divided by usual weight times 100. So let's solve for weight change first. To solve for weight change, we need the patient's usual weight. And 4 months ago, they weighed 152 pounds. And currently, their current weight is 135 pounds. So when we plug into our weight change equation, we take 152, we subtract 135, we divide by 152. Their weight change, the difference between these two numbers right here, 152 minus 135, is 17 pounds. If you take 17 pounds and divide it by the usual weight times 100, you will find the percent weight change, which is 11.1%. Since this happened in 4 months, this is a significant weight loss and an indicator of malnutrition. We'll get back to all of this, but do you see that it's just percent? It's the same skills over and over again. Now, let's do BMI. In order to use this BMI equation, we need the height in inches. And this patient is 5 feet 9 inches. So do you know how to figure out the amount of inches in a foot? It's dimensional analysis. We'll need to convert from feet into inches and then add those 9 inches back on. Okay, so this patient is 5 feet tall. We need to convert those feet into inches. And then we can just add on their 9 extra inches that they have. So the given is 5 feet. There's 12 inches in a foot. This patient is 60 inches tall. Plus their 9 inches, because they're 5'9", they're 69 inches tall. So to find their BMI, you take their weight and you divide it by their height in inches squared. And you multiply it by 703. This right here is the exact same structure as the percent equation. You have a numerator, you have a denominator, and you multiply it by some value, which means if on the RD exam they gave you the BMI, they gave you the height in inches, you could figure out how many pounds they weigh by using the exact same skills we've been talking about. In this case, their BMI comes out to be 19.9, which is a normal BMI. The overall point here is that both the BMI equation and the percent change equation are essential tools for MNT. You'll keep using them, and they're rooted in percents. So as you work through your RD exam preparations, we will solve all the possible math problems using just dimensional analysis and percent algebra. So give each problem your best shot, and I'll see you in the next one.